In this video we're going to be talking about sine, cosine, tangent, cotangent, cosecant, secant. We're not going to be hitting much on the unit circle in this. I just wanted to do some introduction to the graphs and remind you of some of the properties. The graph of sine and cosine you can see in these graphs. Of course, sine, remember, starts at the origin, increases up to pi over 2, then decreases to pi, and then it's negative, decreasing to 3 pi over 2, and then increases back to 2 pi. That's one period of the function, how long it takes to repeat, and then of course it would just continue from there. In terms of the reciprocal function, cosecant, I just want to put a little line in here. Of course, a reciprocal, when sine is 0, the reciprocal function, 1 over sine, would have an asymptote. So just remember that cosecant is equal to 1 over sine. Now, when you're dividing by a really small number, you are really big. Okay, so in these spots, you're dividing by a really small y value. And here you're dividing by a really small y value. And then you divide by a larger and larger value on both sides till right here when you're dividing by 1. Of course, 1 divided by 1 is 1. So that's why this function looks the way it does. Like it comes down here and touches. Oh, I missed touching. Let's come back down. Like that. Something like that. And on the other side, it's the same thing except negative. It looks something like that. Of course, cosine works the same way. In its reciprocal function, secant is equal to 1 over cosine, and of course it will have asymptotes every time that cosine is 0, and its graph will do things like this. This question says if sine is equal to 5/13 and cosine is negative, find the other values of the trig function. Well, I think probably the easiest way to do that is to draw a triangle, and remember that sine is opposite over hypotenuse. So if that's theta, the opposite is 5, hypotenuse is 13. And of course, if I know that sine is 5/13, the one I know right away is cosecant. Its reciprocal function is 13/5. But now I need to do a little bit of math to get the rest, because I need to know what this side is. Because if I'm going to do cosine, I need to know what the adjacent is. Of course, I can use Pythagorean theorem. 13 squared minus 5 squared, the square root is 12. So I can fill that side in as 12. So then, cosine of theta is equal to 12/13. But going back up here, you see it told me that cosine was negative. So I should change that to negative 12/13, and secant, the reciprocal, would be negative 13/12. Now, real quick, I just want to mention, if sine is positive and cosine is negative, sine, remember, lines up with the y's and cosine with the x's. And that has to do with the fact that the sine being opposite, that measures how high, the height of our triangles in the unit circle. And x measuring, or cosine measuring adjacent, measures the x, or the width of that triangle, the base. So if cosine is negative, we're looking for negative x values. Well, of course, negative x values occur over here. Okay. And if y is positive, sine is positive, so the y's are positive, we're looking for y values that are positive up here. So the quadrant in question is the second quadrant. This is where this angle must be located, because that's the only spot where sine is positive and cosine is negative. Well, filling in the last bits of the triangle then, tangent, opposite over adjacent, it will also be negative because remember that tangent is defined as sine over cosine, and sine is positive, cosine is negative, positive divided by negative is negative. And cotangent is the reciprocal, cotangent of theta is equal to negative 12/5. Finally, I wanted to do a little talk on arc length. Arc length is, again, just a measurement of how far around the circle you are. This is just a modification of the circumference formula. Remember, circumference is 2 pi r. And of course, in a unit circle, the radius is 1, and 2 pi radians is the whole way around, so the circumference is 2 pi. Well, arc length, my formula got a little messed up here in transition. Let me write it up. We usually write it as S, that's equal to theta multiplied by r, where theta is measured in radians. So in our case here, we got the angle, 2 pi over 3. The radius is 6. Multiply across, it's 12 pi over 3, which is just 4 pi. Now, it's important to note the angle has to be in radians. So down here with 135 degrees, we've got to transform this into radians. And I did this on purpose so I could remind you of how we do that. 135 degrees, we're going to multiply that by pi over 180 degrees. Now, a couple reasons that this is going to work. First of all, remember that pi and 180 are the same in the unit, or in the circle, that pi is equal to 180 degrees, pi radians. So these two are the same. So essentially we're just multiplying by 1. And multiplying by 1 doesn't change the values, so we can do that. Now if you think to science class with your unit conversions, we've got degrees on top and degrees on bottom, so the degrees will cancel and leave us with 135 pi over 180, and 135 over 180 reduces to 3/4, so it'll be 3 pi over 4. So then we go to our formula, 3 pi over 4 multiplied by 2, 6 pi over 4, which reduces to 3 pi over 2.